Hello, this is Dr. Ayeshola Ogundele of Astronautics for Exploit. In-space manufacturing of asteroids and other space valuable resources. The focus points of my presentation are as follows. In-space manufacturing. In-space manufacturing resonates. Uniqueness of in-space manufacturing and in-space manufacturing requirements. Humans' curiosity and desire to press forward their quest for deep space and long duration of space exploration and venture farther than ever before and utilize the space environment in very different and new ways is opening doors of opportunities for the need for in-space manufacturing, also known as off-Earth manufacturing or in-orbit manufacturing, as the present Earth supply logistics to space will not be able to meet the future deep space missions demand. Venturing into an extended space exploration and space tourism missions to the Moon, Mars, and beyond is ushering in a paradigm shift of using in-situ resources for the manufacturing of the new space infrastructures, such as a sustainable space transportation network, space communications, and a host of others. Availability of space infrastructures will help in the actualization of in-space extraction, manufacturing, and delivering of the wealthy and valuable space resources such as asteroids, moon, and Mars resources for the benefit of humankind and sustenance of humanity's future. The reasons behind in-space manufacturing are as follows. The space environment, in-situ resource utilization, replacement of material production on Earth by production in space for transportation cost reduction and Earth preservation, and transportation of economically viable space resources to the low Earth orbit or the Earth for processing and usage. There are several unique differences between the properties of materials in space compared to the same materials on the Earth. The unique differences can be exploited to produce unique or improved manufacturing techniques. The microgravity environment in space allows control of convection in liquids or gases and the elimination of sedimentation. Diffusion, the primary means of material mixing, allows immiscible materials on Earth to be intermixed in space. In-space manufacturing will be made possible by either using autonomous robotics to extract and manufacture space resources extracted from the asteroids, Moon, or Mars, or using humans with required safety tools. In-space manufacturing. In-space manufacturing is the production of tangible goods beyond Earth, that is, in space. With the actualization of in-space manufacturing, production on Earth will no longer be necessary, and weight and site constraints associated with getting satellites to their orbit will be a thing of the past. This picture shows a vision of a future moon base that could be produced and maintained using 3D printing. Ability to be able to produce satellites and larger structures directly in orbit will revolutionize traditional space system manufacturing. This picture shows demonstration of manufacturing in space. In-space manufacturing resonates. These are some of the reasons that in-space manufacturing is gaining high attentions. Space environment, in-situ resource utilization, Earth observation, and economical viability. Space environment. For example, effects of microgravity and vacuum enable the research and production of goods that could otherwise not be manufactured on Earth. This picture shows Tete's Unlimited Leonite Servicer being designed to service spacecraft in orbit up to 1,200 kilometers. In-situ resource utilization is another rationale. The extraction and processing of raw materials from other astronomical bodies could enable more sustainable space exploration missions at reduced cost in comparison to launching all required resources from the Earth. This picture shows large truss structures being assembled. Earth preservation is another in-space manufacturing rationale. Raw materials could be transported to low Earth orbit where they could be processed into goods that are shipped to Earth. By replacing terrestrial production on Earth, this seeks to preserve the Earth. This picture shows an orbital assembler at work. Economical viability is another in-space manufacturing rationale. Raw materials of very high value, for example gold, silver, or platinum, could be transported to low Earth orbit for processing or transferred to Earth, which is thought to have the potential to become economically viable. This picture shows an artist's impression of an asteroid mining outpost. Uniqueness of in-space manufacturing. In-space versus Earth manufacturing. There are several unique differences between the properties of materials in space in comparison to the same materials on the Earth. The unique differences can be exploited to produce unique or improved manufacturing techniques. This picture shows Mars Science Laboratory rover Curiosity. Microgravity environment is another uniqueness of in-space manufacturing. The microgravity environment allows control of convection in liquids or gases and the elimination of sedimentation. Diffusion, which is the primary means of material mixing, allows immiscible materials on Earth to be intermixed in space. The environment allows enhanced growth of larger, higher quality crystals in solution. This picture shows concept art from NASA showing astronauts entering a lunar post. Space vacuum is another uniqueness of in-space manufacturing. The ultra-clean vacuum of space allows the creation of very pure materials and objects. The use of vapor deposition can be used to build up materials layer by layer, which is free from defects. This picture shows artist rendering of the Restore L servicer, which extends its robotic arm to grasp and refuel a crane satellite on orbit. Surface tension is another uniqueness of in-space manufacturing. Surface tension causes liquids in microgravity to form perfectly round spheres. This can cause problems when trying to pump liquid through a conduit, but it is very useful when perfect spheres of consistent size are needed for an application. This picture shows in-space manufacturing concept. Readily available heat is another uniqueness of in-space manufacturing. Space can provide readily available extremes of heat and cold. Sunlight can be focused to concentrate enough heat to melt the materials, while objects kept in perpetual shade are exposed to temperatures close to absolute zero. The temperature gradient can be exploited to produce strong glassy materials. This picture shows concept of a moon base. In-space manufacturing requirements. Space manufacturing requirement. Due to speed of light constraints on communication, manufacturing in space at a distant point of resource acquisition will either require completely autonomous robotics to perform the labor or a human crew with all the accompanying habitat and safety requirements. If the plant is built in orbit around the Earth or near a manned space habitat, telerobotic devices can be used for certain tasks that require human intelligence and flexibility. This picture shows artist's conception of a mining spacecraft makes a rendezvous with an asteroid. Bulk soil from the moon or asteroids has a very low water content and when melted to form glassy material is very durable. These simple glassy solids can be used for the assembly of habitats on the surface of the moon or elsewhere. The solar energy can be concentrated in the manufacturing area using an array of terrible mirrors. This picture shows concept image of a harvester for deep space industries. Microgravity environment. The availability and favorable physical properties of metals will make them a major component of space manufacturing. Most of the metal handling techniques used on Earth can also be adopted for space manufacturing. A few of these techniques will need significant modifications due to the microgravity environment. This picture shows concept of asteroid mining. For more information, contact Astronautics for Exploit. You've been watching and listening to InSpace Manufacturing of Asteroids and Other Space Valuable Resources, presented by Dr. Anyashola Ogundele of Astronautics for Exploit. Thank you.